In this lesson, we are going to go over function, arithmetic, and domain. So what we're going to do is we're going to perform arithmetic operations with functions and then find the domain of the resulting function. Okay, so with functions, we can add, subtract, multiply, and divide functions. When it comes to finding the domain of the resulting function, it's the overlap or the intersection of the domain of the original function. So we have to look at the domain of the original and the domain of the resulting function. When we divide, we also have to consider the denominator, okay, making sure that that denominator is not equal to 0. Example 1, the functions f and g are defined below. Find the domain of f plus g. Okay, so the domain of f, there's no restrictions, so it's negative infinity to infinity. G of x, there's no restrictions, so it's negative infinity to infinity. So if we were to add these, we would take the overlap or where these two would both be. So if we plot that out, the domain of f, I'll do it in blue, would be all real numbers. The domain of g is all real numbers. So the overlap of those two is still all real numbers from negative infinity to infinity, okay? If you want to see what this looks like when we add these two functions together, we could just add, we would take f, which is x plus 2, plus g of x, which is 3x squared plus 1. And if we simplify, we would get 3x squared plus x plus 3. Okay. Example 2. Find the functions f and g are defined below. Find the quotient f over g of x and give any x values that are not in the domain of the quotient. So looking at f and g, both of them have a domain of all real numbers. Okay, so we're good there, but we're going to find the quotient, so we'll have to be careful of the denominator. So if we find f over g of x, we have x squared minus 2x minus 8 over x minus 7. Okay, what we can't have is we can't divide by 0. So x equals 7 is not in the domain. Okay, one note here is that let's say we were given something like, and I'm going to write it in red. Let's say g of x was x plus 2. Okay, so then f over g would be x squared minus 2x minus 8 over x plus 2. Okay, x cannot equal negative 2 here because of the denominator, even though you can factor the numerator into x minus 4, x plus 2, and cancel these out. We still have to take the domain from what we got originally by the doing the arithmetic, the division of the function, and looking at the denominator. Okay, so I just wanted to make a note on that. A problem like that may appear. Example 3, the functions f and g are defined below. So we have f of x is equal to 1 over x and g of x is equal to 2x plus 3. So we'll first find the domain of each and then we'll perform some operations with these two functions. So the domain of f of x, we have 1 over x and the denominator can't be 0. Okay, so x equals 0 is our only restricted value. If you draw this out, x can be anything else except for 0. It's allowed to go, if you think of domain, this would be allowed to go anywhere in the x values except 0. Okay, so my intervals here are negative infinity to 0, union 0 to infinity. And g of x, there's no restrictions, there's no square roots or denominators, so it's just negative infinity to infinity. Okay, so we'll need to keep that in mind as we're doing these problems. Okay, so part C, find f minus g of x and the domain. So when you're doing subtraction, you want to be very, very careful. You're subtracting the entire g function, so I recommend subtraction and putting this in parentheses because the negative or the subtraction is going to distribute to the 2x and to the 3. Okay, so this is 1 over x minus 2x minus 3. We don't really need to simplify anything here, but we do need to figure out the domain. Again, it's the overlap of the domain of the original. So for instance, because x couldn't be 0 in f, it still can't be 0 here, and there's no other restrictions. So we would still have negative infinity to 0, 0 to infinity. Okay. For part D, when you've got them written next to each other, fg, that means f times g. Okay, so if we multiply the two of them, it's 1 over x times 2x plus 3. And we can distribute, so that would be 1 over x times, 1 over x times 2x plus 1 over x times 3. Here the x's cancel out, so we're left with 2 plus 3 over x. Okay, again, the domains of the original two functions, f can't be 0, g could be anything. Here in the resulting function, we still have x in the denominator, so we're still looking at negative infinity to 0, 0 to infinity. Next, part E. So we have f over g, and we're finding the domain. So we'll take f divided by g. So f is 1 over x, and we're dividing by 2x plus 3. Okay, you can think of this a couple different ways. You can write this out as fraction division. If you do that, we have 1 over x divided by 2x plus 3. We keep the first fraction, change the sign to multiplication, and then flip the second fraction, which gives us 1 over x times 2x plus 3. And I'm going to leave it factored, and that's because we now have a denominator, something extra in the denominator to consider. We've got that 2x plus 3 there. Okay, so we have x times 2x plus 3, and we want to know when that equals 0. I should give myself some more room here. Okay, I'm going to write it over here. X times 2x plus 3 equals 0. So we have x equals 0 and 2x plus 3 equals 0. Solve each of these for x, so x equals 0 stays as x equals 0. We'll subtract 3. Okay, so we've got another value we have to exclude, and that's negative 3 halves. So if we draw our number line, we have 0, negative 3 halves, and it can be anything. The function is allowed to go anywhere but there. Okay, so the function can go from negative infinity to negative 3 halves, negative 3 halves to 0, 0 to infinity. So you would write all of those intervals, negative infinity to negative 3 halves, union negative 3 halves to 0, 0 to infinity. Okay, and this would be our domain of f over g of x. Okay, so we still have to include that x cannot be 0 from f. It also shows up in the denominator of the division of the two. Part F, so we're doing g over f of x and the domain. So again, g is on the top, f is in the bottom. Okay, so when you do this, you are allowed to multiply the numerator and the denominator by the same thing. So that could also help you simplify this. I'm going to multiply the denominator by x, and if I multiply the denominator by x, I also have to multiply the numerator by x. This becomes x times 2x plus 3, and the denominator, these x's cancel out, and you're just left with over 1. Now notice there's no denominator here, but we still have to consider the domain of the original functions. We still have to consider the domain of f and the domain of g. Remember that the domain of f was negative infinity to 0, 0 to infinity. So that still applies here, even though we don't have a domain, because g over f came from f, which had a domain restriction. We have to include it when we're doing the division of the two functions. Last part G, so we have ff of x in the domain, so ff means f times f, okay, or you could see that as gg, meaning g times g. Okay, so we'd have 1 over x times 1 over x, which is 1 over x squared. From f, we know that x cannot be 0, and also from this resulting function, x cannot be 0. We've been discussing that one. That's written as negative infinity to 0, 0 to infinity. Okay. Thank you for watching. If you have any questions, feel free to reach out to me.